Okay. What are the parameters are there? Pressure, temperature, volume, and number of moles of gas, right? So when you think that is the two will be always variable. Whatever the law you are going, always two will be variable. We have to take that is two variable, and two will be constant. Total parameter are there, that is four variable parameters are there. But when you are studying any of the law, that is two is going to be variable and two is going to be constant, remain the constant, all the four law. Okay. So suppose suppose if you are, if I will give the brief description about that one. So P T V N, let me tell you. See, Boyles law, if you are talking about Boyles law. So Boyles law is called isotherm. Isotherm. Okay, isotherm. Isotherm is the temperature constant, T constant. T constant along with N will be also constant. So what will be there? The concept will be that is P proportional to which one will come? V. Because that is isotherm means temperature. Therm means temperature. The temperature is constant. So what are left? That is pressure and volumes are left. Now let us move on the Charles law. Charles law. So Charles law, if you are studying now, so here is what is called isobar. This is the isobaric. I know isobaric. Isobaric. So isobaric means
pressure.
thank you very much. Pressure is constant along with the number of mole is constant. So how can we study here? If you see the pressure is inversely, pressure is going to be inversely related or what? How will be related? How PB is equal to nRT? Na? This is concept. So it is the pressure is constant. So V proportional to what is going to be T. V proportional to T. Is it okay?
Yes.
Now the next one is layer. We are having Avogadro law. Avogadro law. So in the Avogadro law, what is there? This is the simply they are saying the V proportional to N, right? And what is there? Next one is Gay-Lussac's law. Gay-Lussac's law. So Gay-Lussac's law, what they said, that is P proportional to T. Okay, these are there. So what are the constant here? V is constant, right? V constant. What is the constant in this case? What is the constant here? That is pressure and temperature constant. Okay, this is generally called isochoric. No, not isochoric. They will not say isochoric means the volume is constant. Isochoric volume is constant. This is called isochoric. Isochoric. Isochoric means volume constant. Here is the temperature and pressure is constant. Na? So that is the both are constant. That is we cannot use that one. So we are going to study the detail about the Boyles law. Getting my point? What I said this one.
Yes. Yes.
Okay. Now tell me the Boyles law. Okay. Tell me Boyles law, please.
Sir, I have not yet read this.
Not read anything. Okay, Boyles law. What they say at constant. What is there? At constant. Constant. What do you have to take the constant? What you have to take constant?
Temperature and number of moles.
So isotherm is there na? At constant temperature and amount of gas. Amount of gas. Amount of gas. The volume is proportional to what proportional? Inversely proportional. Volume is inversely proportional to pressure. Volume is inversely proportional to pressure. Inversely proportional to temperature. This one means what? Suppose this we are having.
I have one doubt, sir. Sir, I have one doubt here, sir. Firstly, you were telling that this one is having constant temperature and amount of gas. Then, sir, how volume can be inversely proportional?
Okay. Inversely proportional to pressure. Sorry. This is I made mistake. At constant temperature and amount of gas, volume is inversely proportional to pressure. What the here you see, this is suppose the pressure we are having, and some there is volume, right? There must be some volume. Now, if you increase the pressure, what will happen to the gaseous volume? If you increase this, if you are increasing the pressure, what the
If it
volume
will be compressed, volume will decrease.
volume is decreased? Yes or no? So they become the
Yes.
inversely related or directly related?
Inversely related.
Inversely related. So that is what is the V inversely proportional to P. Can we write like that?
Yes.
If you are writing another, say V is equal to, that is if you are removing the proportionality sign, V equal to K by P or K into 1 by P. Yes or no?
Yes.
Another things what we can write, PV is equal to, we can write K. Can we write like that? PV equal to K.
Yes.
Okay. So this is the now the another concept we are writing. What at constant what the constant we are taking? T and N, constant temperature and number of mole, product of what? Product of pressure and P and volume, pressure and volume of gas is always, too much sound is coming, always constant, too much the sound. Pressure and volume of gas is always constant. This is can you understand this one, this line? If you
Yes.
don't,
Yes.
at constant temperature and number of moles, product of pressure and volume of gas is always constant. Yes or no?
Yes.
Hello? This one you need to understand. This one. Okay. Because this asked 2 times in the NEET exam. 2 times. So not only this, so V is equal to K1 by P. This is there. Got it? Now, what that is, if you are matching with the Y is equal to mx plus c. So intercept here is 0. Nothing is there. So intercept will be 0. So if you are making the graph between these two things, this is suppose it is the x-axis and it is going to be y-axis. So x, what you are going to take here? So y-axis you are going to take the volume. Here is volume. Okay. And x-axis what you are going to take? That is what you are going to take. 1 by P, not the directly P, 1 by P. Yes or no?
Yes.
Now, what is the slope? M is the slope. Yes, na? This is the slope.
Yes.
Is it? So what will be there? Positive sign is there. Positive side before the K, na? The slope will be positive slope, right? If the here negative sign, the slope will go negative. Okay. This is the. So slope is equal to, if I will write, slope is equal to, it is going to be K. This is the. So graph of Boyles law, okay, between what the son है, V proportional to 1 by P. Can you understand this one?
Yes.
Okay. So now another things. What will happen? If the temperature I will increase? If I will increase the temperature, suppose constant temperature means what? Constant temperature means what? Constant temperature means that it can be constant at T 100 is constant, can be constant. Then I can say that is T 150 is constant. I can make the constant. Then I will make that is T 200. I can make the constant. So constant anything, any value can be constant. Yes or no? Any value can be fixed that become the constant. Okay. Now here you see. PV is equal to, here I am writing, PV is equal to nRT. This is the ideal gas equation. Ideal gas equation. That easily you can memorize. Now, what we are going to do here, PV is equal to nRT. So P, either you can write V. V is equal to nRT into 1 by what we can write, that is 1 by P. This is there. Right. Now, you by seeing these things, what you will say? V proportional to T. Yes or no? V proportional to T. Is it?
Yes.
Okay. So what we
Sir,
will
V proportional to T, sir, when we can assume that N, R, and P are constant.
okay. Okay, let me make it clear. V, here is the 1 by P. So here you see the graph. These are the graph. These are the graph. Okay. Suppose I will take that is the K1 I am taking, that I am taking K2, then I am taking K3. Okay.
Yes.
Now we have to understand that is which is the going to be high temperature. Which one is the high temperature? Which one is this graph are there that three different temperature, which is at the highest temperature, which will have the high temperature, that we need to know.
Sir, K equal to NRT. Na, so, sir, once will have the highest, K will have the highest NR and T.
Hmm.
Sir, provided instance.
Hmm. Wait. One by yeah, nothing is given in that one. Checking the little bit, checking the book, no?
Yes.
Wait. What we can do, if anything, we can do little bit more here. My video. If anything, we can do. Okay, let me little bit change here. So what the changes we can bring out? PV is equal to nRT is there. Okay. So
Yes.
PV is equal to K, and K nRT. Why I'm writing K? Because here we did na last page.
PV
Where
equal to K and PV equal to NRT. Na, so that is what I wrote.
this one you wrote na, the PV is equal to K. This portion is clear na, this portion PV is equal to K. Yes or no?
Yes, sir, clear.
So here we are putting PV is equal to K. So K proportional to what is becoming? K proportional to from this equation. Can we write K proportional to T? Can we write?
Yes, sir, K proportional.
K proportional to T. So if I will write it K proportional to T means the higher the temperature, greater will be the graph.
So this is what I was telling, sir, in the last 5 minutes. K should be proportional to T because, sir, both PV equal to NRT as well as K.
So which one out of this one, which one is the high one? Which one is high temperature? Suppose 100 degree, 150, 200. Which one is the
Sir,
high?
K1 is high temperature.
K1 is high temperature. So if I will consider that is 200 degrees C, it can be 150 degrees C, that is 100 degrees C. So this type of graph frequently asked in the exams. Okay. Done.
Yes, sir, done.
Okay. Graph between P and V, P versus V. So PV is equal to what is there, Sanoy? PV is equal to constant, yes or no?
Yes, sir.
So suppose I have taken 100 ml. I am taking 100 ml. Okay.
Yes.
So if you are taking the 100 ml, so we have to take the product pressure and volume in terms so that the product should always come 100. Suppose I am taking this one, I am taking the, let me take some value. If I will take the pressure 5, so volume you have to take the 20, yes or no?
Yes, sir.
If suppose pressure I am taking 4, so volume will be 25. Pressure 2, volume will be 50. Pressure 1, volume will be how much? 100.
Sir, 100.
Pressure will be 10. So volume will be 10.
10.
Pressure will be 20. So volume will be 5.
5.
Pressure will be 25. So volume will be 4.
4.
So in each case the constant is coming, yes or no?
Yes.
This is 100, 100, 100. This is also going to be 100, 100 and 100. Okay, now see the graph. So pressure, if I will mention here, what I can mention 1, 2, 3, 4, 5 and 6. See, not 6 here. How can we place like that? What are the value we are having now among the 1, 2, 4? Then what are there? 5. Then what is can 10? Then it can come 20. Then it come 25. Similarly, here you see, it will also come like that. 1, 2, 4, 5, 10, 20, 25. So if suppose pressure is how much? So no, pressure is 1. So what the volume is there? This is the volume and suppose and this is the pressure. Anything you can take. There is no problem. Okay. If the pressure in 1, what is the volume?
Sir,
Volume is,
if pressure is 1,
volume is 100, na? Okay, leave it the 1.
yes.
2, then also problematic only. We have to go the parameter more. We have to go the parameter more and more. Okay, leave whatever the up to 25 is coming,
So
that
we
one
can
use.
start from 4. We can start from 4.
But okay, you start from 4. So if I am taking 4, so pressure will come how much?
25.
25. So this will be that is this one, na?
Yes.
425. Next one, 5. 5 will
So
come how much?
520.
20. Thank you. So here you are saying this one, 520. Next one, which we can consider? 10 we can consider or what? 10.
So 10 and 10. This one here.
10 we can consider. So this one. So it is going to be 10, 10. Okay, next one. What we can take? 20?
So 20, 25.
So pressure will be 20. Pressure will be 20, then it will be 5. Here it is the 5. Okay, next one. Anything else we can take?
Yes, sir. So we can take one more. So here 25 and 4.
25 and 4. So see the graph, you can see somewhere what the graph you are getting. 25 and 4. What the graph you are going to get? This is the hyperbolic graph. This is. Yes or no?
Yes, sir.
So if you see the graph between what we are finding between P and V, this type of graph is coming. And but if you are going this one, V inversely proportional to P, the graph what? Positive slope. And this is what? Negative slope. Why this negative slope? Because that is inversely related. P inversely proportional to V or V inversely proportional to P. So one is increasing, so other is decreasing. Yes or no?
Yes, sir.
So this you understood, huh?
Yes.
Thank you. Now the graph between PV versus P. PV versus P. What the graph you are expecting? So PV is constant. PV is what is? This is the constant. PV is constant, right?
Yes.
So how the graph you are expecting? So it will give the straight line. Always it will give the what is the straight line? Straight line. PV, okay, versus P. So whatever you take the pressure is constant now. P is constant. See, how we can understand this one? 100, 100, 100, 100, everything. Volume you change. Volume you can change here because the P are there, na? Both side P are there. Volume you can change. So how can we get here? which we can, okay. 100 is there, na? PV is equal to 100. So pressure will be constant. So pressure will be constant means the always you have to take the pressure, how much you have to take. Pressure will be always, in all the cases, the pressure will be the same. All the cases, the pressure will be the 100. So the graph will come na straight line graph. That is the PV is constant, na PV is constant. Maybe little difficult to explain. Okay. So this is the straight line graph you will give. This is constant PV graph. Can you understand this one? Can you understand this one? Sanoy, can you understand this graph?
Yes.
Are you sure, or simply you are saying the understanding?
No, sir, understand.
Because PV is constant now, so it will always give the straight line. P and V are changing, so that will give you a different graph.
Sir, there is nothing to understand here. If PV is constant, sir, then definitely y-axis value will be constant.
Okay. If the volume of gas, changes from P1 to V1 to V2, changes from V1 to V2, then okay, changes at constant T and P, at constant T and P, constant what? T and P, T and N, then what will be that? Pressure will change or remain constant?
So pressure
Will be P1 to P2.
P1
P1
to
to P2. Initially, I told na that is a pressure. If you are increasing, volume will decrease. Okay. So if constant T and N are there, so if you are changing, what you are changing, volume you are changing V1 to V2. So pressure will change P2 to P1. So, but the product will be always same. Product will be. So P1 V1 is equal to what is there? P2 V2 is equal to constant. Okay. Explain this one. How? Why we are making equal? How we are making equal?
Sir, if the pressure is more, then the volume will be less, and if the volume is more, then the pressure will be less. Sir, overall, their numerical product will remain constant.
Okay. So means you understood, na?
Yes.
So press P1 V1 is there. So if the V2 decrease, so P2 must have increased. P2 must have increased. P2 increase. Yes, yeah, no.
Yes, sir.
But the product will be always same. Product will be, if it is there, PV is equal to 100 is coming. So it will also come PV is equal to 100 only. So this is. Can we solve some of the problem based on it?
Yes.
Okay, giving you the problem. Please give me one moment. Please, 1 minute. Okay, solve some. Firstly, you solve easy problem, then we will go a little bit more problem. Can I share the problem on WhatsApp to you?
Yes.
Okay. Today your brother is making too much sound or what?
Sir, brother is not making sound, sir. In where the room where we live, sir, just opposite there is one temple, sir. So some puja is being done there. So that is why sound.
Good. Positive vibes are coming to you. Check your
Yes, sir.
WhatsApp.
Yes.
Check the WhatsApp, please. Check the WhatsApp. Can you check the WhatsApp?
Sir, I am online in WhatsApp, sir. Not it is not. Sorry. It is.
Came. You already have seen.
Sir, came. Sir, just now.
Can you share this one? You share last dinner. You will be able to share this problem.
Sir, showing you cannot screen share while other participant is sharing.
Wait. I need to do the setting. That one also I will try to allow. Here. What I can do then? What we can do?
Sir, last day you allowed something like this to share. Yes, last day.
Multiple participants. Multiple. Okay. Done, done. Now check. Now check.
Sir, visible?
Not visible to me. That one. So multiple
Sir,
participants.
you can then stop your screen sharing, so sir, then it will be visible.
Okay, okay, okay. How to stop that is also problem only now. How to is the wait. One participant share at a time. Multiple participants sharing, changing. Wait now. I'm just looking how we have to be very forward in that, but I don't know from where I should stop. More option is there, na? Stop. Anything is there? You guide me. How to stop the sharing?
Sir, at the top there will be written, sir, stop share. Something like this will be written at the top.
Wait.
Sir, at the top of your screen, sir, in the center it will be written, sir, you are screen sharing, stop share. So you check at the top of the screen.
Ah, yeah.
So you can just click on that, it will be on.
Yeah. I am seeing. Okay. Do the problem. Can you try this problem?
Yes, sir.
Ah, ah.
Sir,
Hmm.
so V1 equals to 1 bar is there.
Hmm.
Sir, therefore, V1 equal to 2.27 meter.
Hmm.
Also, sir, if
Hmm.
so like
Uh-huh. A balloon is filled with the hydrogen at room temperature. It will burst if the pressure
P2,
exceed.
sir, P2 will be, sir, P2 will be, sir, P2 will be V2
Uh,
into
uh,
P1, V1, this is the one already given,
uh,
divided by P2, second pressure. So
okay.
this will be P2, we have 0.2 bar, so sir, then B2 equal to this one.
Uh,
Sir, this will be 2 point,
hmm.
one second. So 2.27,
Hmm.
27 by 0.2. So
Hmm.
0.2.
Hmm.
So then this will come 2.27 by 0.2 means 1135. So 11.35 liter.
Uh, uh. So means 11.35 means the if the pressure is exceeding 11.3. So what will be there? Balloon will be burst.
Then balloon will burst.
Okay. So you have seen. Next wait, I am giving you another questions. It is very
Yes, sir.
difficult. Better I will write. Okay, because it is not very much clear. So let me option. Okay. Here is the question. Here is question. What is the questions? If here is there. If pressure increase, if pressure increased 10%, then how much how much volume change? How much volume change of ideal gas? Whatever we are studying, that is ideal gas only. Real gas we have to study later on. Okay.
So real gas will come later, sir.
Yeah, yes. Thank you very much.
This also we are having, sir, V2 equal to V1 by P2. And here it will be the pressure is increased by 10%. This will be
हाँ सनोय.
Sir, 1 second it is disconnected. Sir, like both the devices are gone out. Sir, I'm trying with a new paper. Sir.
Maybe the your side now. What happened? I think.
Probably the problem is in my side only. Sir, I'm trying with another new network.
Okay, okay, no problem.